Welcome you all. In this lecture, we will discuss about the linear regression using stochastic gradient descent algorithm. Here, what is meant by linear regression? Especially, already we have discussed in the earlier classes. Regression means we have to predict the future values. So here, linear regression means the line must be a linear, means the relationship between the input and output must be linear. So here, uh, we are applying the stochastic gradient descent algorithm on regression methods. So if it is a linear regression, then predictor model must be a y cap equal to wx plus b. Here w is the slope, that is a weights. Okay, another terminology is a slope, and b is the intercepting point y axis. So these parameters we have to estimate by using the gradient descent method. So here, after estimating, we have to find the predicted output and actual output. We have to subtract and that find the mean square error and find the loss. That is, the find the loss. If the loss is non-zero, then we have to update the weights. If the loss is zero, then that is we are concluding that weights are properly estimating the input. So in order to find the loss of the gradient, so we have to differentiate because in the loss function, we have to how we have to reduce this loss by changing the weights and bias. The only two parameters available in this model. So dou L by dou W. First I am taking the weight. If I am modifying the weight, then how our loss function is getting reduces. So directly we cannot differentiate because we don't have such type of parameter in this loss function. So therefore, we have to modify like this: dou L by dou W equal to dou L by dou y cap, that is this one, and dou y cap by dou W, that is this one. So if I am cancelling dou y cap, then we will get the right hand side equal to left hand side. The same way, if I am differentiating with dou L by dou B, then here the first term is common, dou L by dou y cap, and second dou y cap by dou B means if you are differentiating with the dou B, then you will get a 1. So therefore, these are the loss gradient functions. Okay, and how we are updating, that means new weights will be updated by using gradient descent algorithm. So W old minus eta into dou L by dou W, B equal to B old minus eta into dou I by dou B. These are the two updating equations. Let us take that they have given the problem is x equal to 1, 2, 3, 4 and targeted outputs are 2, 4, 6, 8. So here, let take the initial values w equal to 0 because I don't know what is the initial value of w and bias. So then therefore we have taken zeros. Okay. Then learning parameter is 0.1. So this is step by step. Let us start. If I am taking x equal to 1 and y equal to 2, then you have to substitute in the predicted model, that is y cap equal to x1 w plus b. If I'm substituting, then we will get 0. Then our actual output is 2, but our predicted output is 0. If I'm subtracting, automatically it is a non-zero. So therefore, we have to update these equations, update the weights and biases. Therefore, apply the gradient descent algorithm. So dou L by dou W, I'm substituting this y cap and y. Y is the 2. We are expecting y cap is our predicted output obtained, the that is the y cap is 0 and x1 is 1. So after substituting this one, you are getting minus 4. By the same way, again we are getting this dou L by dou B. So that is also a minus 4. And updating the equations, that is W old means earlier what we have taken, this is a W. Okay. W old is a 0 and eta is learning rate is the 0.1. Dou L by dou W we got minus 4. So therefore output is minus 4. The new updated weight has been changed from 0 to 0.4. Likewise B also from 0 to 0.4 it has been changed. And in the second input, that is x equal to 2 and predicted output, sorry, actual output we have to obtain, that is 4. That is therefore x2 equal to 2 and y2 equal to 4. So now the weights are already modified, that is w equal to 0.4 and b equal to 0.5. So here again the uh, this we are repeating the predicted model, that is w x2 plus b. After substituting this 0.4 and x2 is a 2, then you are getting 1.2. So 1.2 minus 4, that means again there is a huge difference. That is therefore the loss is very high. Again we have to reduce the loss by using uh, gradient descent algorithm. Here we have to update the weights and bias again. Okay. So by changing the weights and biases, again we got the minus 11.2 k and minus 5.6. Then if I am finding W new, that is W old, here now W old is a 0.4 and B old is a 0.4. After substituting these values, we are getting W new equal to 1.52 and B new equal to 0.96. So in the third data set point, that is what we have taken, x equal to x3 equal to 3 and y3 equal to 6. So for this one, our W new and B new are 1.52 and 0.96. Again, we have to repeat this procedure continuously until the loss become 0 or almost negligible. So this is the way to optimize the parameters in the linear regression by using stochastic gradient descent algorithm. Here again I am telling that that is a learning parameter. Here we have taken 0.1. If you are taking very larger values, then your algorithm quickly reaches the optimal solution, but it is not at all guaranteed. So therefore, the suggested method is the suggested values are for the learning rate is very smaller value. Okay, thank you.